Okay, so let's talk about some details of the assignment for this module. First of all, if you haven't already, you should take a look at the Chapter 3 of the lab manual. It's posted in the assignment instructions and in the Module 1 main page. The goal in this first part of the assignment is to label the elevation of all of the topo lines in this map. The contour interval we're given is 40 meters. So this one, the shoreline, which is at sea level, is therefore 0 meters. And I'll do the first one for you. The one next to it, in the uphill direction, must be 40 meters. Your job is to label the elevation of all of the other lines using the properties of topo maps that we've discussed. I'll give you a few hints. First of all, this one and this one, these bold-faced lines, are the same elevation. It's perfectly legal for two lines on the same map to have the same elevation. Second hint is this stream over here. This blue line represents a stream. And streams, as they flow downhill, they can join together, but they don't split. Say that again. Streams, as they flow downhill, they join together, but they don't split. So given that, you should be able to figure out which way the stream is flowing, and therefore which way is downhill on this segment of the map. The last hint is this feature here. Circular topo lines, like so, indicate a cone-shaped hill or a cone-shaped mountain. But if we're talking about a depression, circular topo lines, if we add in tick marks, as shown in this map, that indicates a roughly cone-shaped depression. Without the tick marks, they're regular topo lines. They indicate this is the uphill direction. With the tick marks, they point in the downhill direction. All right, good luck.
In this part of the assignment, you're asked to produce a topographic map using the elevations given here. And we know two things. One, that the contour interval is 100 meters. So we're going to draw a line representing elevations of 100, 200, 300, etc. And two, the other thing we know is that by definition, a topographic line is a line that connects points of the same elevation. Even if those points aren't labeled on the map, you can figure out where they are. I'll do the first one for you. Let's draw a line representing 100 meters. In this case, we have a point labeled 100 meters, so that's a good starting point, so I'll start there. So I'm going to draw this line and label it 100 meters. So we're going to connect all the points of 100 meters elevation. And so we'll start at the 100-meter point and then walk across the map. Now where do I go with the line? I don't see any points in the vicinity of 100 meters, but I do see a point of 70 meters and a point of 132. 70 is below 100, 132 is above, so 100 must exist somewhere in between those two, approximately in the middle. And so I'll connect to that point. And again, look around. I don't see any points of 100 meters, but I do see a value above 100, 132, and a value below 12. So 100 exists in between them, and closer to the 132, so roughly there. So I'll connect there, etc. Look across the map for points that are above and below the value of the line that you're drawing. 100 meters is much closer to 95 than it is to 160, so it goes approximately there. Then I look around and I see points which are above and above, so 100 can't go between them. 100 is not between 107 and 210, but 100 is between 95 and 107, approximately in the middle, so the 100-meter line must go between them, and then probably somewhere off the map. Everywhere along that line, every point is 100 meters elevation. The next line, 200 meters, we don't see a point on the top labeled 200 meters as we did in the 100-meter case, but we do again have 2 points, one that is above 290 and one that is below 100. So 200 must be in between those two, roughly in the middle. 200 is approximately there. So the 200-meter line starts off the map approximately there, and then you'll continue across looking for points that are larger than 200 and points that are smaller than 200.
Finally, you're going to be using this topo map to create a topographic profile. That is, what does the landscape look like if you were to go from A to A prime along this red line. In the example I gave above, we used a small piece of paper, lay it along the line, make some tick marks, write down the elevation, and then take that small piece of paper to the graph paper. We've made this a bit simpler here for you. We've taken the graph paper and put it directly below the map, so we can skip that middle step of the small piece of paper and just go directly from the profile line to the graph paper. And so what we do is from A to A prime, as you march across this red line, whenever you intersect a topo line, like there, 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 etc., you have to figure out the elevation of that line. And once you have that number, you go vertically straight down on the graph paper and put the dot where it belongs. So I'll do a couple of for you just to get you started. This line here is labeled at 700, and we're told the contour interval is 20 feet. So if this is 700, and this one over here is 800, it must be uphill in that direction. And so if this one's 700, this one must be 720, this one must be 740, etc. So this line, both of these dots there are 720, this dot is 740, and since this here is the 740 line, this one must be also at 740. So that first dot is at 740 feet. So I'm going to go straight down on my graph paper and put a dot approximately there at 740. These two dots, this one and this one, are at 720. So I'll go straight down on my graph paper, which is approximately there. Put the first dot, second dot, etc. Figure out the elevation of all of the topo lines where you cross them on the red line. Go straight down on the map and put a dot at the corresponding elevation. Connect the dots. That will tell you what this landscape looks like exactly from A to A prime. All right, the last thing we need to do in this assignment is calculate what's called the vertical exaggeration. The topographic profile that you drew in the last section shows the correct shape of the landscape, but the way it's been set up in this graph paper, that landscape has been stretched out vertically, shown the steep parts will look a lot steeper than they actually are, etc. So what we like to do is get a sense of just how much it's been exaggerated vertically. So we do that by looking at two things: the horizontal scale, that is something that tells us about the shape of the horizontal part of the map, and the vertical scale, the profile that you just drew. So we need to know the horizontal scale, and that's given to us here. It's written like this: 1 to 24,000. What that means is that 1 inch on the map equals 24,000 inches out in the real world. Or we could rewrite this: 1 inch is the same as 2,000 feet. So there's a horizontal scale. 1 inch on the map, if you measure 1 inch on the map horizontally, that corresponds to, in the real world, 2,000 feet on that landscape. Our vertical scale we need to figure out. So here we're going to go down to our graph paper and figure out a similar 1 inch equals so many feet by simply measuring 1 inch on the graph paper and figuring out how many feet on the graph paper it corresponds to. So you're going to take your printout and get a ruler and measure 1 inch from the 700 feet up, and then figure out where on the graph paper that 1 inch lands. And so just hypothetically, I'm making this up. If you were to measure 1 inch is there, that's 870 feet. If we subtract where we started from, 700 feet, your 1 inch corresponds to 170 feet of vertical elevation. Okay. And so your vertical scale, you're going to get 1 inch equals some number of feet. I'll let you figure that out. That goes here. And then our vertical exaggeration you calculate by taking your horizontal scale, which we figured out is 2,000 feet, divide by the vertical scale, which you're about to figure out. That goes here, and you'll be done. You'll get a number which tells you how many times the profile has been exaggerated or stretched vertically compared to the horizontal. Okay? So depending on how you print this and how your printer scales the images that you print, you might get a slightly different number than 70 than your neighbor, or from me for that matter. But roughly speaking, the vertical exaggeration in this example is about 15. If you get something wildly different than that, go back and try again on your calculations. Alright, that is the end of Assignment 1. When you're finished, please upload it to the Assignment 1 Dropbox, either as a Microsoft Word document or as a PDF. Whatever you do, please submit one file. What students like to do, which works very well, is to print out an assignment like this, take pictures of it, but please do assemble all of those photos into one file and submit that together. All right, thanks very much. Let us know if you have any questions.